Okay, my dear students, before we go to conduction in compounds, there is a very important thing to note. That is, what is the difference between the Arrhenius and the modern concept? Okay, the modern concept of electrolytic dissociation. So, what is the difference between the Arrhenius theory, versus the modern theory of electrolytic dissociation? Okay, the only difference is that Arrhenius considered that water ionizes electrolytes. That is, water is the only thing that will ionize electrolytes. But according to modern research, and it is a fact that we have studied this in chemical bonding as well, that modern concept considers the electrolytes are ionic. Electrolytes are ionic because electrovalent compounds are ionic in nature. Even in the solid state, they are ionic, and their ions are held by strong electrostatic forces which make them immobile. Water renders these ions mobility by breaking the electrostatic forces. So what is the difference? So let us take an example to understand this difference. According to Arrhenius, if you take an electrolyte, for example NaCl, NaOH, any electrolyte you took, he says that water H2O can only break these electrolytes into their constituents. Okay, and water can only ionize them. Sorry for the spelling mistake. Ionize them. Water can only ionize. This is according to Arrhenius. But according to the modern according to the modern theory, we know that electrovalent compounds, that ionic compounds or electrolytes are ionic even in the solid state. So if you took NaCl, the structure of NaCl is like this: Na plus Cl minus. So they are held together by this force of attraction. This bond is known as the electrostatic force of attraction. Okay, electrostatic force. And why electrostatic force? Because these are charged entities which are held together strongly by a force that is known as electrostatic force of attraction. Okay, so this only notion tells us that electrolytes even in the solid state are ionic in nature. You can see the ions are held together, so only they are held together by strongly by an electrostatic force. So in the solid state they are not mobile, but they are ionic. But they are not mobile. That is, they can't move. So if you took a solid NaCl, you can't pass electricity through it. Why? Because the ions are immobile. Okay, so to pass electricity through any substance, the ions should move. Okay, and how they move? So according to the modern theory, water is not ionizing it. That is, it is all itself ionized. Okay, it's itself ionized. Water only breaks this electrostatic force. So according to the modern theory, water just breaks this electrostatic force and make the ions separated, thereby making them immobile, that is, by making them move. Okay, and hence current electricity can pass through the electrolyte. I hope you understood.